drift velocity. For that, first we consider a conductor, and we know conductor there are large number of free electrons. Large number of free electrons are available, and these electrons are in motion due to the thermal energy. Thermal energy, these electrons are in motion inside the conductor. But we cannot say there is a current flowing through the conductor because all the electrons are in random motion. They are moving in a zigzag manner. So average speed is there, but average velocity is 0. The speed, very high speed they are moving, electrons inside the conductor. But when they move, they will hit the ions of the conductor. They will hit with the other electrons of the conductor. See, hitting here, again bouncing from there to another ions, positive ion it is hitting, and like this it is hitting, and it is a zigzag manner it is moving, and net velocity, average velocity is 0 inside the conductor. So children, when we are not applying any potential difference, is there any average velocity? Average, not speed. I am not asking about speed. Average velocity. Is it have any average velocity?
No, ma'am.
No average velocity. Okay, no average velocity. But when we apply potential difference, we can see what happened when we apply potential difference. They will see, instead of hitting here, see when we apply potential here, this and this positive. So electrons will be accelerated. We know. For example, apple fall towards the earth because of gravity, and it is accelerated. Similarly, when we apply positive potential here at this end, electrons are accelerated. Electrons negative charge, this end positive, so they will be accelerated towards this positive of the battery. So you may be thinking the velocity increases like that. But it is not like that, children. When it is accelerated, again the collision happens. So instead of hitting here, it sometimes hit here, and like that. And slightly only it will be accelerated because collision is more than. So accelerated, when the electrons are accelerated, again it will hit with the conductor, it with the ions of the conductor, and then the slight direction change only happens, and that will be towards the positive of the battery. So it drift, but it velocity increases, correct, but it will hit with the ions of the conductor, again its velocity is lost. That is what is happening. So when there is no potential difference, they are moving in random manner, but when we apply potential difference, they will be slightly accelerated in the direction of opposite direction of the electric field. That means towards the direction of positive of the battery, they will be accelerated, but that acceleration will not continue for long. Why? Because they will hit again, when it accelerates, it will again hit with the ions of the conductor, with the other electrons of the conductor, that will hit. Again, well, when it hit, energy is lost. So again, that continuously we are applying the battery here. So again, so we can see a slight drift in its velocity only, we can see. Slight drift in its velocity. So anyway, at last the electrons will move with a constant velocity. So what all things are happening here, children? When we are not applying any potential difference, when we are not connecting any battery, they will move in zigzag manner and average velocity is 0. But when we apply potential difference, they actually accelerated with this positive of the battery. And if E small e is the charge of the electron, capital E is the electric field setup. Due to this battery, we create an electric field. This end becomes positive, other end becomes negative, and electric field is set up. And we know equation for the force acting on the electron. Anyone? Small e is the charge of the electron. Capital E is the electric field setup. What is the force, children? What is the force acting? Capital E.
Small e, capital E.
Small e into capital E. ആരാ പറഞ്ഞത്? ലക്ഷ്മി പ്രിയ?
Yes, teacher.
Very good. Small e into capital E is the force acting on it. Small e into capital E is the force acting on. So it will be accelerated, but that acceleration will not continue for long. Why, children? That is not continuing.
Because it is hitting.
Because it is hitting. Who answered that?
Mehrunisa.
Mehrnisa, very good. It hit with the conductor, and that ions of the conductor. Okay. Ions of the conductor, and it lost that its gained velocity is lost. Gained velocity is lost. So, but anyway, that will be moving towards the positive of the battery, towards the positive of the battery with a constant velocity. That is happening. Direction is towards the positive of the battery against the electric field. Electric field direction positive, negative, towards left. But they are moving opposite direction of electric field towards the positive of the battery. So they move with a constant velocity. That I will show you. You can see that. See electrons movement. When we apply potential difference, we can see.
Any current.
Explanation I will give you, children. You can see the figure.
Okay. So now comes the question, what happens when you do put a battery? What happens then? Well, now, because of the battery, the electrons will experience a force and they will accelerate. So let's say the force would be in this direction, over here, because they're being attracted by the positive charge of the battery. You can also think in terms of electric field, but as of now, it's not necessary. So
Teacher, sound കുറവാണ്.
now, as a result,
Okay.
the electron will now take a little different path. So because it is being accelerated towards the right, instead of bouncing from here, instead of going here, maybe it bounces off a little bit towards the right. This is the new path. Okay. Then from here, it might, instead of bouncing over here, it will bounce somewhere over here. Then instead of bouncing from here, it goes the constant.
See, they are moving with a constant
So
velocity.
let me write that down. These electrons are acting, and it's this motion.
You just observe. See, when we apply potential difference, that motion you observe. Force is acting towards the positive of the battery with the small e into capital E. That force, electrons are moving, and they are moving in this direction towards the positive of the battery with a constant velocity. Don't listen, just observe. I will explanation I will give you, children. You can see the motion.
That
See,
contributes to the electric current. This drift motion. What's important is that this
see their motion. Just observe the motion. See, they are moving with a constant velocity. Understand? That is happening. Okay. So here that is drift velocity. Drift velocity is actually a constant velocity gained by the electron when a potential difference is applied. And because of that velocity, we can get a current here. Electrons move towards the positive of the battery, and the electron flow, rate of flow of charges will constitute a current. So here what we have seen, what is drift velocity? It is the average constant velocity attained by the electrons when we apply a potential difference. Understand? Otherwise velocity is 0. Average thermal velocity is 0. But when we apply potential difference, they gain a constant. That word is very important there. It attain a constant velocity when we apply potential difference. That's why the current is constant here. Because of this potential, we are not getting a varying current here. It is when we apply battery here, we are getting a constant current because electrons are moving with a constant velocity. So actually they are gaining velocity, increasing its velocity due to this force acting on it. Force E into capital E, that is the force acting on the electron because of the electric field. Okay, children? So I understood what is drift velocity. I will ask you.
Yes, ma'am.
So then you know that another term that you have to study is relaxation time. What is average relaxation time? That is the time between two successive collisions. See, in this case, we know when we apply potential difference, the electrons are drifted. We cannot use accelerated. electrons drift. They drift again. So, again hit with the other ions, again drift like that. Electrons are drift velocity. So, when they move, they will collide. We cannot say we are not colliding. So, they collide but they reach another point, again it collide and reach another point. Anyway, at last all the electrons will move towards the positive of the battery against the electric field. That is happening here. So, the time between two successive collision, not any two collision, children, it is the time between two successive collision. First the electron hit here. So, time between two collision. Then the electron hit here. Time between two successive collision, that is known as average relaxation time. So, we have to derive the relation between current and drift velocity. So, when you got the idea, we can do it easily. Okay. Suppose in this conductor, number of electrons per unit volume is small letter n. You take unit volume. Unit volume means 1 centimeter cube or 1 meter cube, like that. Unit volume of the conductor you take. And there are n electrons. How many electrons? Small n. N electrons. N electrons per unit volume. What is the volume of this conductor? If L is the length and A is the area cross section of this conductor, what is the volume? This is a cylinder form. The wire is actually a cylindrical. Okay. So, A is the area cross section and L is the length. What is the volume, children? Volume of this conductor. A is the area cross section. L is the length. A into L. Very good. A into L is the volume. Prakasam is outside. Okay. A into L is the volume. I am asking question. N is the number of electrons per unit volume. Then what is the total number of electrons in this conductor? Volume of the conductor is A into L. Capital A is the area cross section. L is the length. A into L is the whole volume of the conductor. Number of electrons per unit volume is N. So, what is the total number of electrons in this conductor? Anyone?
N into L.
Very good. N into Al. N into Al is the total number of electrons. If small e is the charge of electron, what is the total charge? Total electrons are NaL. What is the charge? Small e is the charge of electron, 1 electron. So, what is the total charge? N into A into L is the total number of electrons. NaL into E. Very good. NaLe. NaLe is the total charge of the electron. Then current, how will you calculate if you get total charge? Current Q you got, Q equal to NaLe. Then current equation tell. Current
I is equal to Q by T.
Very good. I is equal to Q by T. So, I is equal to Q by T, Q NaLe by T. And T you can just can't write T there. And T means the time taken by the electron to cross the conductor. That depends upon the drift velocity of the electron. So, we know that how much time it takes to cross this conductor, this length, how much time the electrons are moving with a constant velocity, drift velocity, and how much time it will take to cross this length. That time you have to calculate. That is time with a constant velocity. If it moves, time we can calculate, children. Time, what is the time? Time equal to L is the length, velocity is drift velocity, constant velocity, Vd, suffix d, Vd, drift velocity.
By L.
Distance by time, velocity, see distance എന്താണ് ചെയ്യേണ്ടത്? ടൈം കാണാൻ എന്താ ചെയ്യേണ്ടത്? ടൈം ഈക്വൽ ടു constant velocity.
Distance by velocity.
Distance
by velocity.
by velocity. L by drift velocity. L by Vd. So, NaLe by L by Vd. L and L cancel, Vd comes to the numerator, NaE Vd. That is the equation for current. I equal to NaE. I will show the page now, and I will again ask. See, we are going to derive the expression between current and drift velocity. Here, Vd, V suffix d, we denote drift velocity, V suffix d. VD. Drift velocity is the average constant velocity attained by the electron when we apply a potential difference. And here we consider L is the length of the conductor, A is the area cross section of the conductor, then volume will be A into L. Small n is the number of electrons per unit volume, therefore total number of electrons in the conductor is NaL. Therefore total charge is NaLe. Then current is Q by T. Q is NaLe by T. What we substitute for T, children? Average. So that time taken by the electrons to cross the conductor, what is it? Time taken
L
by VD. L by VD. VD is the drift velocity. Then L and L cancel, we get NaEVD. Very important relation, current and drift velocity. I will show the page. Drift velocity, so explanation is given here. Relation between drift velocity and current, that is explained here. Same thing what we explain here, that is explained. Yes, see, current I equal to Q by T, total charge equal to NaLe, T equal to L by VD, L and L cancel, we get I equal to NaEVD. What is N, children? N. Dibangsha, what is N here? Let Dibangsha. ശ്രദ്ധിക്കുന്നുണ്ടോന്ന് അറിയണ്ടേ? ദീപാങ്ഷ, വാട്ട് ഈസ് എൻ? ഉറങ്ങാൻ തോന്നുന്നുണ്ട്, കാലത്ത് എഴുന്നേറ്റ്. ആദിത്യൻ, വാട്ട് ഈസ് എൻ ഹിയർ? കണ്ട, കുറച്ച് പേര് ശ്രദ്ധിച്ചിട്ടുള്ളൂ, ബാക്കിയുള്ളവരൊന്നും ശ്രദ്ധിച്ചിട്ടില്ല. മിഥുൻ, വാട്ട് ഈസ് എൻ? പോട്ടെ, വേറെ ചോദിക്കാം. വാട്ട് ഈസ് എ? മിഥുൻ, വാട്ട് ഈസ് എ? കാലത്ത് 7 മണിക്ക് എന്നിട്ട് എല്ലാവരും ഉറങ്ങാണ്. കുറച്ച് മുടിക്കിടന്ന് ഓൺ ചെയ്ത് വെച്ചിട്ട് കണ്ടില്ലേ, ഒരാളും ഇല്ല, ആകെ ഓൺ ചെയ്തവർ മാത്രം ഉണ്ടാവും. എന്താ ചെയ്യാൻ, പ്രധാനപ്പെട്ട പോർഷനൊക്കെ ബിഗിനിങ് ആണ് തന്നെ. നീരജ്, വാട്ട് ഈസ് എ ഹിയർ? നീരജ്, റെസ്പോൺസ് ഇല്ലെങ്കിൽ മാർക്കില്ല കേട്ടോ. റെസ്പോൺസ് ഇല്ലെങ്കിൽ മാർക്കില്ല, 2 മാർക്ക് പോയി. മിണ്ടില്ലല്ലോ. ഇന്ന് ചോദിച്ചവരാരും ആൻസർ പറഞ്ഞിട്ടില്ല. കുറച്ച് പേര് എടുത്തപ്പോൾ ആൻസർ പറഞ്ഞു, ശരിയാണ്. ഞാൻ എഴുതിയേക്കട്ടെ, അല്ലാണ്ട് ശരിയാവില്ല. നിങ്ങൾ ഇങ്ങനെ വരിക കാലത്ത് എഴുന്നേറ്റ് ഞാനിവിടെ കിടന്ന് എക്സ്പ്ലെയിൻ ചെയ്യുക കാര്യങ്ങൾ. നിങ്ങൾ അവിടെ നിന്ന് ഉറങ്ങുക സുഖമായിട്ട്. ഓക്കെ. മുഹമ്മദ് ആദിൽ, വാട്ട് ഈസ് എ ഹിയർ ഇൻ ദിസ് എക്സ്പ്രഷൻ? മുഹമ്മദ് ആദിൽ, നോ റെസ്പോൺസ്. വാട്ട് ഈസ് എ? ഏരിയ എന്നാണോ ഞാൻ പറഞ്ഞത്? ഏരിയ ഓഫ് ദ കണ്ടക്ടർ ആണോ എന്ന് പറഞ്ഞാല്? വോളിയം. അപ്പൊ എ എന്താണെന്ന് പറ? എന്റെ എൽ വോളിയം. അപ്പൊ എ എന്താണ്? മിത്ര, വാട്ട് ഈസ് എ? ഒരു സിലിണ്ടറില് എന്താണ്?
ക്രോസ് സെക്ഷൻ ഏരിയ.
ക്രോസ് സെക്ഷനിൽ ഏരിയ, കറക്റ്റ്. ഏരിയ ക്രോസ് സെക്ഷൻ ആണ് കേട്ടോ. ഏരിയ ക്രോസ് സെക്ഷൻ. അപ്പൊ പകുതി മാർക്ക് കിട്ടും മുഹമ്മദ് അലി. ഓക്കെ. ഏരിയ ക്രോസ് സെക്ഷൻ ഇൻറ്റു ഹൈറ്റ് അല്ലേ വോളിയം. അപ്പൊ എ ഇൻറ്റു എൽ. എ ഇസ് ഏരിയ ക്രോസ് സെക്ഷൻ ഓഫ് ദ കണ്ടക്ടർ ആണ് കേട്ടോ, അല്ലാണ്ട് ഏരിയ ഓഫ് ദ കണ്ടക്ടർ അല്ല. ഓക്കെ. ദെൻ ഇ, വാട്ട് ഈസ് സ്മോൾ ഇ ഹിയർ? നീരജ്, what is small e? Neeraj, what is small e? Tamanna, what is small e? Tamanna Belluraj. Tamanna Belluraj. Tamanna Belluraj ഇല്ല എന്ന് തോന്നുന്നു. Tamanna ഷാജു. എല്ലാ ക്ലാസ്സും കാലത്തെ ക്ലാസ് എന്ന് പറഞ്ഞ ഇതാണ്. സ്ഥിതി ഇപ്പൊ മനസ്സിലായില്ലേ? ശ്രീരാഗ്, ശ്രീരാഗ് എല്ലാവരും ഓൺ ചെയ്തിച്ച് ഇന്നുറങ്ങണം. സാഗർ സാഗർ എല്ലാവരും വിളിക്കട്ടെ, ആരൊക്കെ എനിട്ടിരിക്കുന്ന അറിയാലോ. പ്രിയ ഋതു പറഞ്ഞ പ്രണവ് ഋതു പറഞ്ഞ വാട്ട് ഈസ് സ്മോളി?
electrons,
ഈ എന്താണ് അവിടെ? ഇലക്ട്രോൺ എന്നാണ്, ഇലക്ട്രോണിന്റെ പേരാണ്. വാട്ട് ഈസ് ഈ ദർ സ്മോളി? ഇലക്ട്രോണിന്റെ എന്താണത് സ്മോളി? ഏ
all free electrons in the
എന്താണ് നമ്മളിവിടെ ഈ കൊണ്ട് റെപ്രസെന്റ് ചെയ്യുന്നത്? ഇവിടെ ഇത് NaLe. വാട്ട് ഈസ് ഈ?
total charge due to
NaLe ടോട്ടൽ ചാർജ്. വാട്ട് ഈസ് സ്മോൾ ഇ? അറിയില്ല. റിയ NaL means total electrons. And we multiply with E. Then we are getting total charge. Then what is small e?
of electrons ആണ്.
എന്താണ്? നിവേദിത, വാട്ട് ഈസ് സ്മോൾ ഇ? നിവേദിത, what is small e?
Charge of an electron.
Yes, correct. Charge of an electron. Nivedita answered. ഇത് പറഞ്ഞ പകുതി മാർക്ക് കിട്ടുള്ളൂ കേട്ടോ. ചാർജ് ഓഫ് ഇലക്ട്രോൺ. ഇനിയും പെർഫോമൻസ് നോക്കും. അറ്റ് ലാസ്റ്റ് കുഴപ്പമില്ല എന്നുണ്ടെങ്കിൽ 2 മാർക്ക് ഇടും, അല്ലെങ്കിൽ 1 മാർക്ക് ഇടും കേട്ടോ. അതായത് റെഗുലറായിട്ട് വാച്ച് ചെയ്തുകൊണ്ടിരിക്കും നിങ്ങൾ ആൻസർ പറയുന്നത്. ഓക്കെ. So, E is the charge of 1 electron. Total number of electron NaL. NaL into E is the total charge of electron. And drift velocity, time taken by the electrons to cross the conductor. That is distance by its constant velocity, drift velocity. So, L by Vd. L and L cancel. Vd is the drift velocity. So, we get the expression I equal to NaEVd. And what is N? What is N? What is N?
Number of electrons per unit volume.
Very good. And Jnanaprakash got answer. Jnanaprakash. So N is the number of electrons per unit volume. Okay. So I think you understood. Those who listened understood. Others I can't tell because they are sleeping. They are not listening. What can I do? Okay. What is drift velocity? Krishna Sri, what is drift velocity?
Yes, ma'am. It is the average constant.
Constant?
Hello?
Okay. Yes, I can hear.
When we apply potential difference.
Average constant velocity acquired
Acquired by electrons.
By?
When we apply potential difference.
Applied. When a potential difference is applied. Very good. That is what I told. Those who listened understand. Thus I can't do anything. If you want, you have to listen. Everything we are telling, the board exam board is making this internal exams very important nowadays. So what is the relation between current and drift velocity? Krishna Prabha. Current and drift velocity.
NaEV into Vd.
Left side, what is there?
I is equal to Na into E into Vd.
Vd, okay. So that is the equation. Then some terms you have to connect. Current density, last day we have seen. From this also we can find current density. Current density is a vector quantity. Current per unit area, I by A. A is taken to left side. So you get NeVd. NeVd. All the equations study very well. And this time multiple choice questions, first term exam fully multiple choice. So each and every equations you have to note. Okay, children. So current density is equal to I by A. NeVd. Okay. Mobile, yes.
മാം എക്സാമിന്റെ അന്ന് എഴുതാനുണ്ട് ടൈപ്പിംഗ് ഉണ്ടാവും മാം.
No writing this time, physics. I don't know. The other subject also will be multiple choice. Sometimes I don't know about maths. Maths that they will tell. Other subject because a terminal exam is multiple choice. Term wise, first term exam. CBSE made multiple choice only.
അല്ല മാം ഈ പരീക്ഷയിലെ ഈ ഗൂഗിൾ ഫോമില് ടൈപ്പിംഗ് ഉണ്ടാവും.
No, no. We are following the pattern given by board. Okay.
Okay, ma'am.
That's why no typing. For the term 2 exam only you can expect writing. Okay.
Teacher, why we
Viva is conducting now. No, I am conducting Viva. This is Viva.
this lesson?
In between, I will be asking question, and for your response, I am giving mark. Okay. Every day we have to take your response every day, and you are according to your performance. Some children you have seen, some children are not at all answering anything. How can we give mark? So if you answer, at least the response is important. They are not at all responding to the question. I don't know, you can tell, no problem, next time I will give them chance, but they are not even telling that. What they are doing there, they may be sleeping. That is why no response we are getting here. So for your response, those who are responding very well during class, I am asking questions in between, and for that performance, not only for that chapter, Viva is the internal asking questions. Okay, for your response. Okay, mobility, another term that you have to study is mobility. Drift velocity per unit electric field, that is mobility. Drift velocity by electric field, that is known as mobility. So drift velocity and electric field are directly proportional. When we apply more potential difference, when we apply battery of instead of 5 volt, if we use a 10 volt battery, drift velocity increases. But that will be constant, children. Velocity increases and drift velocity is directly proportional to electric field. Drift velocity is equal to a constant in the electric field. That constant is known as mobility. So mobility is drift velocity per unit electric field. Very important relation. Mobility. Mobility directly proportional to what, children?
Drift velocity.
Drift velocity.
That mobility,
Electric field.
drift velocity directly proportional, inversely proportional to electric field. Vd, mu equal to Vd by E, directly proportional to drift velocity. Okay. Mobility of charge, yes, SI unit is here, drift velocity meter per second by electric field volt per meter. So we got the unit meter square, this come to numerator, meter square, second raised to minus 1, V raised to minus 1. Okay. Ohm's law. Only coming, Ohm's law. Relation between mobility and relaxation time. Relaxation time, I told you, it is the time elapsed
Time between two successive.
yes, very good. Time between two successive collision. That is relaxation time. And relation between mobility and relaxation time. We have drift velocity Vd equal to mu into E. Drift velocity Vd is also equal to A into T. That we haven't taken A into T. Okay, let me see that page. V equal to U plus AT. From that we got this equation. U is the initial thermal velocity of electron, that is 0, A into time, relaxation time. With that we got that formula. I will take the expression for drift velocity. That is not here. It is not here. Some other page.
And teacher, relation between drift velocity and current in a mole ഉണ്ട്.
ഉണ്ടായിരുന്നോ?
ആ, ആ.
Okay, let me see. relation between. This is drift velocity. Here it is given. Where is it? I am not able to see. Not
Teacher, relation between drift velocity and current in the മൂലത്തെ topic അതല്ലേ ma'am?
this page.
Wait, yes ma'am.
But that expression I haven't written, I think. V equal to U plus AT. That is not written. See, when the electric field is applied, each electron experiences an acceleration. Acceleration is equal to force by mass, E by m. As electrons accelerate, they collide with the electrons and ions of the conductor. Thus, they lose energy and finally cause a small velocity towards the positive potential. This constant velocity of free electron is called drift velocity. That and all okay. And you can see the drift velocity is defined as the average velocity gained by the free electrons of the conductor in the opposite direction of external applied field. Vd is of the order of 10 raised to minus 5 meter per second. This is the drift velocity order 10 raised to minus 5. Actually, I will tell that. That equation is not there. Have you got this expression? V equal to U plus AT. From that, V equal to U plus AT. U is 0. T equal to L by U. Okay, that's not. Okay. You can see study Ohm's law that I will give you later. Drift velocity A into T. V equal to U plus AT, children. U is 0. Initial average velocity is 0. And we know when a potential difference is applied, then only it is gaining that velocity. And at that time, initial velocity is 0. So V equal to U plus AT. U equal to 0. A into T. T is the relaxation time. Average relaxation time. So A into T. A is substituted here. A acceleration that I have given earlier. Acceleration is force by mass. Force equal to capital E into small e by mass into T. So tau is the average relaxation time. Just like tau it is written. Tau, average relaxation time. And from 1 and 2 we can write this is both are drift velocity expression. Both are drift velocity expression. So we can equate them. Right sides we can equate. So mu into capital.
Teacher,
Yes.
ഈ സിമ്പിൾ ടോർക്കിന് യൂസ് ചെയ്യണല്ലേ?
Yes, same symbol we use here. Tau.
റിലാക്സേഷനും സെയിം സിമ്പിൾ തന്നെയാണോ ടീച്ചർ?
Yes, relaxation time. Tau.
Okay, ma'am.
Then E get cancelled here, children. Then mu equal to torque into average relaxation time into E is the charge of electron by m, mass of the electron. So we got another expression, that is expression for mobility and relaxation time. So for doing problems, all the equations you should know. That is average relaxation time into E by m. Clear, children, these two equations? Drift velocity directly proportional to electric field. Drift velocity is equal to constant in electric field, mu into E. Drift velocity is equal to U plus AT. U is 0. A into tau. Tau is the relaxation time. Average relaxation time. Time between two successive collisions. So A is substituted. A is force by mass. Force equal to capital E into small e by mass into relaxation time. So E and E get cancelled. We get mobility equal to average relaxation time into charge of electron by its mass. Okay. And Ohm's law experiment, next what we have to study. And we already studied Ohm's law. What is Ohm's
Teacher.
law?
Teacher, what is current density?
Current per unit area. Unit area.
Okay.
That is current density. And current density is a vector quantity. Okay. Current is a scalar, but current density is a vector. Okay. Ohm's law everybody knows. be simple, just remember this formula. V is proportional to I. Potential difference across a conductor is directly proportional to current, or V is equal to IR. But some quantities we have to keep constant, otherwise they will vary. V will not be proportional. What we have to keep constant? Temperature and temperature and other physical conditions remain unchanged. Then V is proportional to I. If temperature vary or pressure, etc., some things vary, then they will not be proportional. So that condition we have to tell whenever we state Ohm's law, provided the temperature and other physical conditions remain unchanged. So Ohm's law, just to remember this formula, V is proportional to half mark you will get. And what is V? Potential difference applied across a conductor. What is I? The current. When we apply potential difference, current flows through the conductor. So V is proportional to I. Everybody should know what is Ohm's law. V is proportional to, just tell that. Then you can explain what is V? Potential difference applied across a conductor. What is I? I is the current flowing through the conductor. When we apply potential difference, current flow through the conductor. So very, very basic formula, very, very important formula. Current electricity, that is the basic formula, Ohm's law. Nobody can't say, I don't know Ohm's law. See, that is the basic thing. V is proportional to I. The current flowing through a conductor is directly proportional to the potential difference across the ends, provided the temperature and other physical conditions remain unchanged. V is proportional to I. V is equal to a constant into I, R into I, where R is called resistance of the conductor. SI unit is resistance. SI unit, you are knowing that. What is SI unit of resistance? Ohm. Oh, correct. And yesterday I told resistance depends on different factors. Which are they?
Material and dimension.
Yes, material and dimension. Dimension means?
Length,
area. Yes, directly proportional to?
Length.
Inversely proportional to?
Area.
Okay, R equal to rho L by A. That we have seen. Rho is the resistivity or specific resistance of the conductor. And reciprocal of resistance, do you know what is it? Reciprocal of resistance? Conductance. Reciprocal of resistance is conductance. So its unit will be ohm raised to -1, or it is also known as MHO. See, inversing it. Not inversing, that invert. M is written first. MHO. തിരിച്ചിടാന്ന് പറയില്ല. MHO. Conductance 1 by R. So ohm raised to -1, or Siemens. It is named after the scientist Siemens. 31 ആയി, ബാക്കിയൊക്കെ പോയി. This is Ohm's law circuit, children. So Ohm's law, see, actually, have you done in lab this experiment, Ohm's law, in 10th standard? Yes or no?
No, teacher.
No? No. Actually, if the school was functioning, you were able to do this, no, children. But I will show the experimental setup. Experimental setup is there, and that is very good. Not this one. Where is it? Ohm's law. It is not. I will show you next class. Okay. Experimental setup. What all things are there? Actually, I kept it, but now it is not same. So again, I'll show that page. Okay. Then next day I will show you the what all things are used in Ohm's law. So what is Ohm's law, children? Just tell in mathematics. Mathematically, how can write Ohm's law? V equal to I. V equal to R into I, or V equal to IR. V is proportional to I. Where R is the resistance. Then V is the
Potential difference across the conductor.
Yes, very good. I is the
Current.
flowing through the conductor. Okay. So here Ohm's law verification. We have to do Ohm's law verification. V is proportional to I. That scientist says, and we have to verify with this experimental setup. We can see a battery eliminator, a key is there, and a ammeter is there, a rheostat, and you can see a resistance wire and a voltmeter. Okay.